Okay, welcome to the November 2023 paper 1H from the Edexcel for MA1 series. Alright, question number 1 is a Venn diagram. First question straightforward, just list the numbers that are in the circle labelled A. I like to do them in ascending order. For A intersect B, that's 5 and 15, and for A union B complement, that's the stuff outside of both of them. Very straightforward first question. Question 2, notice the fully bit. The fully bit tells you that you could accidentally do a partial factorisation. Don't do that. 6p times by 2q minus 3. For the 56 metal bars, if we sum the 3 different types of bars, we'll get 56, so that allows us to construct an equation. I've put brackets in there just to help you see where the 3 parts come from, although it should be fairly clear. Collect the like term, 6y plus 2 is equal to 56. Subtract 2 from both sides. Divide both sides by 6. We get y equals 9. Substitute that into the expression for the zinc, number of bars that are zinc, and you get 13. Question number 3, a percentage profit question. So 1500 plus 36 lots of 450. Will be the total that Nina pays. Work out the difference between that and the amount Joshua spent, and then divide that by the amount Joshua spent. Multiply by 100, and it gives us the profit as a percentage. It comes out as 41.6%. Question number 4, discrete random variable. So the probabilities will always sum to 1. That allows us to construct an equation, 0.58 plus 2x plus x equals 1. 3x equals 0.42, divide both sides by 3, x is equal to 0.16. 250 spins, 0.58 chance of it being a blue, multiply the two together, we'll get 145 as an estimate for the number of times it will get land on blue. Alright, the 3 semicircles question. Well, it tells us that A to C and B to, is equal to B to D is equal to C to E, which are 20. That gives us the diameter of each of the semicircles. Half of that is the radius, which will be 10. The perimeter of this shape, well, we have the 3 semicircles, that's the curved circular bits, and then there's 2 radii at the top and the bottom. Each one of the semicircles has got half of 2 pi r, if you just prefer pi r, and then add 2 lots of the 10 for the 2 radii. It gives us 114 when we plug that into the calculator. Question 6, sort of a reverse percentages question. So if you want to take a sixth off, you'd multiply something by 5/6. So if we divide by 5/6, it will reverse that process. So A will be 168. For B, 20% off is the same as multiplying by 0.8. So if we divide by 0.8, it will reverse that. Gives us 170 for the second one, and the difference between those two numbers is €2. For 7, finding the highest common factor of 2 numbers, you can just read this off if you prefer. Some people like doing intersecting circles, for the intersection being the highest common factor. Whatever way you want to do this one, absolutely fine if you end up with the correct answer. If you've just read it off, it's the smallest power of each of the shared numbers, so 5 cubed plus 7 squared plus 11 to the power of 4 for the highest common factor. Question 8, a linear inequality. The easiest thing to do here is to add 4 to both sides, subtract 3x from both sides, then divide both sides by the 5. You get x is greater than or equal to minus 6/5. The 3 regions, x is less than or equal to 7, y is greater than or equal to 2, and y is less than or equal to x. You can test a point in those if you want to. Perhaps a 0.43 would be a good one to choose if you did. 9a standard form, 0.000587 for the first one, 8.4 times 10 to the 7 for the second one. And for part C, we can set up a little equation. 8.5 times 10 to the 10 is equal to k times 1.47 times 10 to the 9. Divide both sides by 1.47 times 10 to the power of 9 to work out k. It doesn't ask us to show calculations here, so and the numbers are relatively small, so you can just plug that into your calculator, and k comes out as 57.8. Question 10. I'm going to label the base of the left-hand triangle as y. We'll get tan of 40 is going to be the opposite over the adjacent, so 8 over y. Quick rearrangement of that, y is equal to 8 over tan 40. You can leave it as 8 over tan 40 if you want to, or you can write it as 9.53. As long as you don't round part way through the question, use the answer function on your calculator. Subtract that from 22 to find the base of the right-hand triangle, comes out as 12.46, etc., etc. And therefore, inverse tan of the opposite over the adjacent gives us 32.7 degrees for x. Question 11, the lowest common multiple of 4 and 6x is 12x, so that's what I'm going to aim for my common denominator. If you just multiplied 4 and 6x to get 24x as a common denominator and added them, that's fine. As long as you simplify at the end, you'll be able to factorise out to 2 and cancel it. Either way, you should end up with 7x plus 10 over 12x. Question number 12, substitute your numbers in, -1, 3, 1. It gives you -1, and then the last one is 3. We'll plot those points on the graph. Just be careful, the scaling on the x-axis is different to the scaling on the y-axis. And then, hopefully more carefully than I have a go at drawing a line that passes through those points. Apologies for my poor graph. For the graphs, -1 over x squared, it's always going to be negative, is the way to work this out, so it's got to be d. It's the only option. Question 13, we've got 80 bits of data, so the median's at the 40th. Read it off, it comes out as 25. Anything between 25 and 25.5 will be accepted. For the 50 seconds, we can run that up and run that across. It's about 74. So that leaves us with 6 that are more than that, and 6 out of 80 as a percentage is 7.5%. Anything between 5 and 7.5 is deemed acceptable. Question 14, circle theorems. Just be careful on this one. It does say give reasons for your working. You need to give at least 2 out of the 3 justifications in this question. Okay, so we know that angle ACO is going to be 52 degrees because O to A and O to C are radii and therefore the same length, meaning this is an isosceles triangle, and base angles of an isosceles triangle are always equal. We now have 2 out of 3 angles in the triangle, so we can work out angle AOC, that's the angle at the centre of the circle, by subtracting 2 lots of 52 from 180, comes out to 76 degrees. Again, because it says give reasons for your working, I am going to put that angles in a triangle sum to 180. Often that seems obvious, but will count as one of your justifications. Lastly, ABC is going to be half of 76, so 38 degrees for ABC. And the reason is that the angle at the centre is twice the angle at the circumference. If you put the angle at the circumference as half the angle at the centre, that's absolutely fine. There are variations on how you can phrase it, but there has to be some key words that are seen for it to be acceptable. And the final answer is 38. Question 15, make n the subject. So first thing I'm going to do is multiply by the denominator, multiply by 3n minus 4, so x lots of 3n minus 4 is equal to 3p plus n. Expand out the left-hand side, 3nx minus 4x is equal to 3p plus n. Then I'm going to bring the n's onto the left-hand side and the non-n's onto the right-hand side. So subtract n from both sides, add 4x to both sides. If you've done 3p plus 4x, that's absolutely fine. Then factorise the n out on the left-hand side, and we can divide both sides by 3x minus 1 to give us an expression for n. And that's 4x plus 3p over 3x minus 1. If you've got an equivalent fraction to that, that's absolutely fine as well. Question number 16, so it gives us a cubic, wants us to find the point on the curve where the gradient's a third, so what we're doing with gradients is telling us to differentiate. So dy by dx, we multiply by the power, subtract 1 from the power, the differential is 12x squared minus 8. Then replace dy by dx with a third, and we can solve the equation, and that will give us the x coordinates where the gradient is a third. So I multiplied everything by 3, brought the 1 onto the right hand side. You can do this in different ways. If you brought the constant onto the left and then square rooted carefully, taking both the positive and negative square roots, that would be absolutely fine. But x comes out as plus or minus 5/6. For the gradients question, it gives us that 24 of the oranges are less than 20 grams, and that tells us the area of the most leftily rectangle. So if I divide 24 by 20, 20 is the base of that rectangle, we get 1.2. So I know it's got a height of 1.2, and from that I can quite clearly see that the scale is going up in ones. Then we want medium ones, so we've got 35 grams and 55 grams. So there's two rectangles we can work out there. So 15 times 2.2 and then 5 times 1.8 gives us the two areas, add them together, and we get 42 oranges. Question 18. If I continue the line for due north at B, if I continue that down into the triangle, I can split that section up into two parts. Angles on a straight line sum to 180, so that right hand part is 48, and then on the left hand side it's going to be 54 degrees because that is an alternate angle to the 54 degrees we're given of due north at point A. Those sum to 102 degrees, so we now have enough information to use the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Plug that in, square root it, AC comes out as 9.80, etc, etc, etc. I won't round part way through, so I'll use the answer function on my calculator. I'll add the other two lengths to that 9.80 and divide it by the 6 kilometers per hour that Melo is walking at. Gives us 3.634. Now the question wants us in hours and minutes. There's a few ways of doing this. It's a bit fiddly. There's a few ways of doing it. That effectively you could have just subtracted 3 to get rid of the 3 hours, and then worked out what 0.634 was as sort of out of 60. I've gone with the multiplying by 60 to work out the total number of minutes. I've subtracted 180 minutes from that because that's my 3 hours, leaving me with 38 minutes left over. So 3 hours, 38 minutes is the final answer for 18. Question 19 is the arithmetic sequences one. Well, it gives us quite a lot of information. It gives us the first term, which is 3, and the common difference, which is 4. We can just read that off. I'm going to let capital N be the position of that last term in the sequence, the position of x in the sequence. And so I know that the sum of n terms is going to be, that's capital N terms, the sum of all the terms is going to be 7,260, so I can plug it into the formula for summing N terms, which is given in the formula sheet at the very front, N over 2 lots of 2a plus n minus 1d. And we actually have a quadratic equation set up, so we can solve this quadratic to work out N. First thing I'm going to do is simplify the stuff that's inside the brackets as much as possible. It reduces down to 2 plus 4n, or 4n plus 2. Then I'll expand it out, giving me n plus 2n squared equals 7,260. The question asked me to show clear algebraic workings, so if we're ever left with a quadratic on a question where we show clear algebraic working, we do need to solve the quadratic by showing a method. You can't just plug it into your calculator and draw the solutions out. So I'm going to use the formula here. I think probably the most straightforward, so minus b plus or minus the square root of b squared minus 4ac all over 2a. I'm showing all of the numbers being plugged into that formula. And you get two values of n out, n being 60 or minus 60.5. Well, n is a position of a term in a sequence, so it's got to be a positive integer. Negative 60.5 does not make sense, so I'm going to rule that one out, and I know that there are 60 terms in this sequence. Then, to find out the value of x, in the sequence, I'm going to use un equals a plus n minus 1d. That one's not given in the formula booklet, but it's not hard to learn, it's fairly short. And so for our last term, it's going to be 3 plus 60 minus 1 lots of 4, and that comes out as 239. Okay, question number 20 is the probability question. It tells us that the probability that two coins have a mean value of 10, well, that means they both have to be 10, is what that's really saying. So it's got to be a 10 twice in a row, a 10 and a 10, so probability of x being 10 times the probability of x being 10, or if you prefer, x being 10 squared. It's 49 over 121, so the probability of x being 10 is 7/11. Therefore, the probability of x being 20 must be 4/11, because those are the only two possible outcomes. So to answer the question, for a mean value of 15, you can have a 10 and a 20, or you can have a 20 and a 10. They'll have the same probability. So to keep this short, I'm just going to double it. Probability of x equals 10 is 7/11 times the 4/11, probability of it being a 20, and then times it by 2, 56 over 121. Is the probability of it having a mean value of 15. Alright, so for the triangular prism question, I'm going to work out the area of the shaded face DEF and multiply it by the depth of the shape, that's the length AF. Because it's a triangle, I want the base and the height. The base is DE, the height is FE. We have that d to f is 28, and so we can use basic SOHCAHTOA to find those two other angles. Then to work out AF, we can use Pythagoras on ADF. That gives us the three calculations we need. If you worked out the individual values, that's absolutely fine. Just be careful not to round part way through a question, or leave your answer in surd form and use those. That's not a problem at all. Whatever way you've done that, the volume comes out as 7,638 centimetres cubed. Alright, question 22. Apologies for my picture. There you go, that's supposed to be a circle. We have point P on the circle with coordinates 8, -10, and we've got a tangent at P that passes through the y and the x-axis. Apologies for my tangent as well. Okay, so we want to find the coordinates of the 2 points Q and R. Q is the intersection with the x-axis, R is the intersection with the y-axis. I've drawn a little radii from the centre to the point P there, radius, sorry. The gradient of O to P is going to be negative 10 over 8, or if you prefer, negative 5/4. The gradient of our line L is perpendicular to that, so we're going to take the negative reciprocal of negative 5/4, which is 4/5. That allows us to construct the equation of line L. We know the gradient, we know that it passes through P, so we can substitute negative 10 and 8 into y equals mx plus c. Or if you used y minus y1 equals mx minus x1, that's absolutely fine as well. Anyway, c comes out as negative 82 over 5, and because c is the y-intercept, we can deduce that r must be the coordinate 0, negative 82 over 5 straight away. To find our point Q, well, our equation of line L, y equals 4/5 x minus 82/5, we can substitute y to be 0 because the y-coordinate of any point on the x-axis is always 0. So substitute y to be 0 and solve the equation to find the x-coordinate. We can add 82/5 to both sides, times both sides by 5, divide both sides by 4, and we get x equals 41 over 2, or 20.5. That gives us the coordinates of Q, and that gives us two sides of a right-angled triangle, O to Q and O to R, so we can plug in Pythagoras to find the difference between them, and it comes out as 26.3 once you've used Pythagoras. Okay, question 23. This question is all about scale factors. It gives us the numerical scale factor of areas, so 7776 to 486. I'm going to simplify that straight away by dividing both sides by 486, and it comes out nicely as 16 to 1. To find the scale factor of lengths, I can square root both sides, and so the scale factor of lengths is going to be 4 to 1. And then if we take the scale factor of lengths and cube them, we get the scale factor of volumes. And so the scale factor of volumes here is 64 to 1. Now, it gives us some information about both shapes for the scale factor of volumes. We know that it's 8 to the power of x to 2 to the power of x plus 4. So if we take the smaller shape, solid B, and multiply its volume by 64, we'll get the largest shape. Now 2, 8 and 64 are all powers of 2, so I'm going to rewrite all of them as powers of 2. 64 is 2 to the power of 6. 8 to the power of x is the same as 2 cubed to the power of x, or if you prefer 2 to the power of 3x. Then combining the powers on the left hand side, we can work out that 2 to the power of x plus 10 is equal to 2 to the power of 3x. So x plus 10 is equal to 3x. Subtract x from both sides, halve it, x must be 5. So to find the height of B, well, we know that the scale factor of lengths is 4 to 1, so let's find the height of A and then divide it by 4 to get the height of B. So the height of A, 3 to the power of x, or 3 to the power of 5, over 4, and that comes out as 60.75 centimetres. The last question, well, shift to the left of 4, so A is going to be minus 4, and if you spot, it's gone from plus 2 to plus 8, so that's 6 up there. For P, the amplitude is trebled, so P is 3, and that is 45 units to the left of where you'd expect a cosine graph to be, so Q is going to be 45. Well done if you did that.